Hi everyone, this is Zakir and this is the fourth video in our module functions. Check the previous video if you missed it in the description below. In this video, we will be looking into a few more types of functions. A function can be defined by more than one formula. These functions are known as piecewise functions. It can be defined for different intervals in a given domain. Consider the function f(x) equals x plus 1 when x is greater than or equal to minus 1 and less than 0. This can be sketched onto a graph as shown here. We don't extend the line beyond these two parameters minus 1 and 0 because that's the condition of x. So this would be y. This line is y equals x plus 1. Remember, we use a bold circle to indicate that the respective point is included and an empty circle to indicate that the point is excluded. The next formula, f(x) equals x squared, can be drawn from 0 to 1 as follows. Here, x can be equal to 0, so it's a bold circle, but x cannot be equal to 1, so it is an empty circle. f(x) equals 2 is basically a constant function and can be graphed as a straight line as shown here. Next, let's see what a modulus function is. The modulus of f(x) is denoted as shown here, f(x) within these two lines. In a modulus function, the range, or in other words, the y values are always positive. Consider these graphs y equals x and y equals modulus of x. Here you may notice that we get negative values for y, that is the range, when x is less than 0. Since the range is always positive in a modulus, when x is less than 0, the graph of y equals modulus x is the reflection of this graph. So this is how we draw it. This is y equals x. This is y equals modulus of x. In other words, for the values where x is less than 0, we draw the graph of y equals minus x. So this would be y. Actually, this is the graph of y equals minus x. And this part would be y equals x. As a whole, this whole graph is y equals modulus of x. This can also be represented as a piecewise function as follows. Modulus of x is positive x when x is greater than or equal to 0, and it is negative x when x is less than 0. So, if we are asked to draw a modulus function, we first draw the function without the modulus, and later we find the image of the part where the range is negative. Now, let's find out the inverse of a function. An inverse of a function f(x) is written as f inverse x. Consider this function f(x) equals 3x plus 7. There are two steps to find the inverse of the function f(x). First, we substitute f(x) by x and x by f inverse of x. Then the second step, we subject f inverse x. So x minus 7 divided by 3. So f inverse x would be x minus 7 divided by 3. Finally, this is the inverse of the function f(x). Consider the functions f and g, where the function f maps x to y and the function g maps y to z. This means that we can create a new function which maps x directly to z. This new function is called a composite function and is written as g of f of x, which is equal to g in brackets fx. This is not a dot. It is basically like a small o, and this is pronounced as g of f of x. The diagram below shows this mapping. So this would be fx, and this would be gx, and this would be g of f of x. This would be f inverse x. Consider these two functions fx equals 4x plus 5 and gx equals x squared minus x. So g of f of x can be written as g and fx in brackets. So what we do is, in this formula gx equals x squared minus x, we substitute fx instead of x. So that would be fx squared minus fx. Then we substitute 4x plus 5 into this equation. So that would be 4x plus 5 whole thing squared minus 4x plus 5. Finally, when we simplify the equation the usual way, we would get 16x squared plus 36x plus 20. Please see the link in the description below for the exercises on the above topic. Attempt the questions and check your answers before moving on to our next video. Now for the tip of the day. Remember that FOGX is not equal to G of f of x, and also FGX is not equal to fx multiplied by gx. Many students unfortunately make these mistakes. This is proved in the exercises given to you. So with that, we wrap up this video. Please subscribe to our channel, like our Facebook page, and share this video to your friends and to anyone who will benefit from this video. If you have any questions or any topic that you find difficult to understand, please ask us in the comments below. We are always ready to help you. Until then, take care.